we will take a look at titrating a weak base with a strong acid. This is like what's done in section 15.4, except they don't give this specific example, and I think it would be good to see one here, so that's why I'm showing it. Let's take a look first at the titration curve. So if you have a weak base, you're going to have a pH greater than 7. Okay, and then when you titrate it, eventually when moles of acid equals moles of base, you're going to have your equivalence point, but this time you're going to have the weak base is going to be converted to its conjugate acid, and you're going to have a pH less than 7. Anything beyond that, you're going to have excess acid, and then it would be an excess acid problem once you get beyond point C. So looking at this, I have NH3, which is a weak base. So OH minus equals the square root of Kb times NH3. It's just your typical weak base problem. Anywhere between point A and point C, you're in the range where you're going to take pH equals pK plus the log of NH3 over NH4 plus, and I think it's easier to use POH equals pKb plus the log of the acid over the base. I think that's the easier way to go when you're in that buffer zone, which would be in this range right here. Notice this at 50 milliliters will be your equivalence point. At half the equivalence point, POH equals the PKB for this right here. Okay, what happens at point C? You are actually at you've converted all of the NH3 to NH4 plus. So you're actually solving this like a weak acid problem, and the equivalence point, and notice because it is a weak acid, NH4 plus, you get a pH less than 7. Here it ends up being 5.37, and then beyond that, it's like an excess H plus problem. Let's look at the details of the calculation. And so I think I'm going to scroll this up and make this bigger, quite a bit bigger to see. So you kind of get the big picture focus, and then every detail is kind of shown if we go to this next piece. So first off, what were we doing? We have 100 milliliters of the weak base, and we're titrating with 0.10 molars HCl. So right away, I'm noticing my acid is twice as concentrated, so it's probably going to take half as many milliliters to get to the equivalence point, and that's why the equivalence point is 50 milliliters instead of 100 right here. Okay, let's do just our weak base, NH3. We know the molarity, we know the Ka value, we take the square root of what we multiply together, and I figure out POH is 3.02, which would be a pH of 10.98. Okay, let's say I add 10 milliliters of 0.10 molar HCl. So that tells me I have 0.0010 moles of H plus is added. Okay, so what that's going to do is convert NH3 to NH4 plus. So that 0.0010 moles is going to be subtracted from the NH3, making it 0.004, and it's going to be added to the 0, making this 0.0010. I showed this doing pH equals pKa. You have to go through K equals Kw to get there. I think it's a lot easier to just do POH equals pKb plus the log of the acid over the base. And when I do that, the pKb is 4.75, and the log of the acid over the base is a 4-to-1 ratio, which ends up being what, minus 1 to 4 ratio, so it ends up being minus 0.60. I get a POH of 4.15 or a pH of 9.85. Okay, as I keep going in the titration, eventually I reach the midpoint where I have 0.025. I'll keep scrolling up here. 0.025 moles of HCl are added, and that converts this 0.0050 to NH4 plus. So half of it gets converted, half of it's NH3, half of it's NH4 plus. So POH equals, I should have probably wrote that in there, POH equals the PKB, which is 9 point, I'm sorry, the PKB would be 4.75, and then the pH would be 9.25. Okay, I'm going to just skip ahead to the 40 milliliter case right here and kind of skip this one. But what if I have 40 milliliters of acid? Again, 0.005 minus 0.004 leaves me with 0.001, and I have 0.004. So this time I have more of my conjugate acid than my base. It still is coming from this base, so it's still going to be a basic solution, but POH equals PKB plus log of the acid over the base, 4.75 plus 0.56, or 0.60, I get 5.35. Subtract that from 14. It's still basic at 8.65, but it's getting more acidic there. Okay, what happens when I reach the equivalence point? Then all of the NH3 is converted to NH4+, so it should be an acid at that point. So I have no NH3 left, I have all NH4+, and then I do it like a weak acid problem where H plus equals Ka times NH4+. Notice I have to take my moles divided by my total liters there, the 50 milliliters that I added and the 100 that I started with when I get my concentration. So be careful with that step. I put that into the Ka value. I got that because that was Kw over Kb. I have this, and ultimately I can solve and get a pH of 5.37. So all of the base was converted to the conjugate acid. So it's an acid, it's going to have a pH less than 7, yet it's not all that much less than 7. Now, what happens if I go beyond that? Then I get an excess H plus, and the pH tends to drop quite drastically. So let's say I go to 60 milliliters here. I have 0.0060 moles of H plus. It neutralizes. So what happens, the NH3 neutralizes it and converts it to NH4 plus, which doesn't affect the pH very much, but I have 0.0010 moles of excess H plus, and that's what's really going to affect the pH. So yes, there is additional NH4 plus that was converted to. That's not going to affect the pH relative compared to the H plus, which is 0.0010 moles over 0.16 liters, right? 60 plus the 100 original, and I get a molarity, and I can solve for pH. And if I went to 75 milliliters in the 0.10 molar, much the same story, except I use 75. So I got 0.025 moles, I have 175 milliliters. So I divide that, and the pH is 1.85. It's already low. It's not going to be able to drop too much further with more excess. So just going back to this equation and what we did. Okay, so initially we have the weak base. Okay, then in anywhere in between A and C, you use Henderson-Hasselbalch. At point B, which is the midpoint for half the equivalent point, POH equals the PKB. Okay, at point C, all the NH3 got converted to NH4 plus, so it becomes a weak acid problem. And then after that, it is an excess H plus problem. Hope that helps. Thanks for watching.